Right, so this video is a continuation of the first video, which essentially was explaining how to break down forces into their X and Y components, right? So we talked about how for ramps and inclines, we are going to be looking at, we're going to slant our X and Y so that we don't have to resolve normal, friction, maybe force applied. Sometimes this might be a bit more tricky, but the one that we just need to worry about most of the time is going to be weight, right? So once you break it down, this is basically going to be your cos of theta, and this is going to be your sine of theta, right? So if you want to understand that a little bit more, please go watch the previous video. But for now, we're going to start to look at some questions. All right, so now the first example is going to be, it says, a 12 kg box is pushed up a slope with a 30-degree incline with a force of 100 newtons, right? So we're applying a force of 100 newton up the slope, okay? And moves at a constant speed, right? So these are one of the things that we just always need to highlight. So we have the applied force, that's perfectly fine. The moment they tell you constant speed, this tells you that there is no acceleration up the slope. So again, if our y is perpendicular to the slope and our x is up the slope, that means that acceleration in the x direction is equal to 0 meters per second. Right, perfect. Right, and then, so that's all the information that we're given. Calculate the normal force acting on the box. All right, so before we start to calculate forces and all that stuff, let's go back to what we were doing before and break down all the forces that we were given. All right, so we're going to represent our center of gravity, which is the point on which all our forces are going to act, with a point. Right, now let's list all the forces that we have, right? So we have, if this is let's actually just do this. All right, so this is our x-axis. And this over here is our y-axis. Okay, let's list all the forces that we have. All right, so we have force applied going up the slope in that direction. Force applied, which is, I think it is 100 newtons. Let's just push this that way. Okay. We also are going to have, because you're on a surface, you have normal force. That's going to be N, so we don't know what that is just yet. Right, so that's going to be the first question. We have, because we haven't been told about it being on a smooth surface or frictionless surface, so that means we're probably going to have a frictional force. Now, how do we know that frictional force is going down the slope? Because we know that it moves up along the slope. So if frictional force is always going to oppose motion, so if you're moving up the slope, frictional force is going to be down the slope. All right, and then you have this weight over here. Right, now, as you can see, all of the other forces are either on the y-axis or along the x-axis, whether it's positive or negative. The only one that's a problem is going to be the weight, right? And in the last video, essentially, we talked about the fact that this weight, this angle, if this angle is theta, that means that angle is also theta, right? So in order for us to get the y and the x component of w, right? So if this is w, we need in the x direction and in the y direction, this is going to be, if this is a triangle or rectangle, sorry, a triangle, right angle triangle, this is going to be your adjacent. This w is your hypotenuse, so this becomes w cos theta. We explained why in the last video, right? So you can just go back and watch that if you haven't already, right? So this is going to be w sine theta. So this means that the four forces, this is going to be, so you have w sine theta over here. Actually, because we know theta, let's just write what that is. W sine 30. All right, so now you have two different forces. You've got F, frictional force, and W sine 30 both going down the slope. You also have W cos, then you have 30 over here. Okay, so just that there's no confusion, I'm just going to remove these. So we've talked about how to work through that. Okay, so these are our five forces. Let's actually just circle all of them. You have normal force, applied force, weight going downwards, 1, 2, 3, 4, 5, right? So these are your five total forces. So we've broken everything down into we've made sure that everything is either along the y or along the x. Why does this matter? Because once you have it in these directions, then we can start to bring in resultant forces, because we can individually add and see what's the resultant in the y direction, what's the resultant in the x direction, right? So just going back to part A. Part A is asking for the normal force. The normal force is in the y direction, right? So it means we have to use, if we have an unknown, we have to ask ourselves, okay, we have an unknown force. What is our resultant force in that direction? In order for us to know what the resultant force is, we need to figure out what the acceleration is. So this goes back to your flat surface questions, right? If something is moving along the slope, it's going that way. It's only moving either up or down the slope. If it's not moving perpendicular to the slope, there's no motion to go that way or down into the slope. This means there's no acceleration in that direction. So the y direction has no acceleration. And why is that important? Because Newton's second law tells us force is equal to mass times acceleration in the same direction. So if I have no acceleration in a particular direction, it means I have no resultant force in that same direction. So if I have no acceleration in the y, if acceleration in the y is equal to 0, then my resultant force in the y direction is also equal to 0. So that means all the y forces have to cancel each other out. So now in this case, whether you want to say, well, my up forces must equal my downward forces, what we are going to do is we're going to say anything that's going up away from the slope is going to be positive, right? And then to get the resultant force, we're going to say, we're going to add up all the forces in that direction, in the y direction. So upward forces, you've got normal force. That's going to be positive since it's going away from the slope. You also have weight. Now weight is going into the slope, right? So it's going into the road, into the surface. So that's going to be negative. So that's going to be minus W cos 30. All right, W is also, remember, weight is equal to mass times acceleration due to gravity. So this is going to be the normal force minus mg cos 30. So this would give me the resultant force in that y direction. And we know that this is supposed to equal 0, right? So since it equals 0, now we can make n the subject of the formula by taking this to the other side. When you take it over, it's going to become positive. So mg cos 30. So that means your normal force is going to be equal to your mass, which is 12 kgs. That's in its SI unit. So we can just write it as 12. Multiplied by acceleration due to gravity, which is 9.81, multiplied by cos 30. So now we can just simply put that into our calculators. So 12 times 9.81 times cos 30, that should give you a normal force of 101.9 newtons. 948, or however many significant figures, that's fine. You know, we're just going to write it to one decimal place. Right, so that is the normal force, right? So again, the approach is similar to flat surfaces. You're still saying, okay, if I've got unknown forces, I can just trace back from Newton's second law and say, well, in order for me to get, if I don't get the resultant force directly from the question, do I have acceleration? If I have acceleration, then I can get the resultant force. If I have the resultant force, then I can get an unknown force in the system, right? So this, essentially, we just have to be able to play around with different forces, resultant forces, and Newton's second law. All right, so this is what we just need to keep on practicing and practicing until you're comfortable with. Right, part B says calculate the friction acting on the box. Now this is in the x direction because friction is along the x direction. So we have an unknown force yet again, right? We don't know what the force is, but the question is, do we know what the resultant force is? We haven't been explicitly given in the question, right? But again, we can still use Newton's second law. Do we have acceleration then? This is now the next question. Yes, we do, because in the question, we saw that it's moving at a constant speed. Constant speed means acceleration is equal to 0. The 0 acceleration, right? So that's going to be part B. The x direction is equal to mass times acceleration in the x direction, right? So 0 acceleration means mass times 0. This is going to give us an answer of 0 newtons. So your no acceleration in that direction means that you have no resultant force in that direction. Right, so so now we know what the resultant force is, and the approach becomes exactly the same as the last part, right, where we say, okay, we have to now define a positive direction. I usually want to say the direction that the object is going is going to be our positive. So that means that if we're going upward, up the slope is going to be positive. So anything that's going up the slope is considered positive. Anything that's going down the slope is considered negative. All right. I just realized that this question might not give us a positive answer. Right. So let's just say 12 multiplied by 9.81. Okay, actually, no, it should be fine. Okay, should be fine. Right, I come up with these questions out of my head, so sometimes it doesn't make sense. The answer doesn't make sense. So it looks like it's going to. So we're going to continue the question, right? So any force that's going up the slope is positive. Any force that's going down the slope is negative. So we have three forces in the x direction, 1, 2, 3. So now we just need to make sure we've put the signs in the correct forces. So if applied, that 100 newtons is going to be a positive force. So positive 100, that's our F applied. The frictional force is going down the slope, so that's going to be negative. The weight component that's going down the slope is negative since it's going down the slope, right? So that's going to be minus W sine 30. So this would give us the resultant force in the x direction. Now the question is, what is that resultant force? That resultant force, as we can see from there, is equal to 0. So we can then say force of friction, it's negative over here, so we're just going to shift it to the other side of the equation so that it becomes positive. And then now we've got 100 minus W sine 30. All right, so that's going to be force of friction is equal to 100 minus W, which is mg sine 30, that's going to be 12 times 9.81 times sine 30. Put that into your calculator. Times sine 30. It gives you an answer of 41.14. So three significant figures, that's 41.1 newtons. So the reason why I was checking if this makes sense is because I thought I'd made the mass a little bit too heavy for this force over here, right? So if the weight were too heavy, it means that this number becomes really big, right? So it would have given us a negative friction. Negative friction basically means that, well, that means friction is in the opposite direction. Friction in the opposite direction now means that we are now moving downwards. Because that weight is just so great, this object would not be able to move up the slope. It's actually moving down the slope. And your friction is now in that direction as well as your applied force. But this question, the answer kind of made sense, so we'll keep it there. All right, perfect. All right, so that is how we're going to break it down, right? So hopefully this kind of makes sense. But the approach is basically exactly the same as before. Once you've resolved it into the y and x components, you then find the resultants. Using the resultants, you can also find the acceleration. Or, just like we've done in this question, it could be the exact opposite. Use acceleration to get resultant force. Then use resultant force to get an unknown force in the system. Okay, that is part 1 of that question, or at least example 1 for this video. Example 2, right, says a heavy box with a mass of 600 kgs is released from rest at the top of a smooth ramp. So it goes from here and is allowed to slide down. Actually, let's just mark. We have the mass. Once you have the mass, it means you've got the weight. Weight is, in your exam, again, just make sure that you've written this explicitly. Your examiner can see that you've actually calculated the weight, you know what it is, right? So this is going to be mass times acceleration due to gravity, which is 600 multiplied by 9.81, right? Actually, we're not going to calculate it just yet. Is released from rest. This might be important. At the top of a smooth ramp. So smooth ramp tells us that this is frictionless. So the force of friction is equal to 0 newtons. And allowed to slide down until it reaches the bottom. The ramp has a 45-degree incline and a height of 30 meters. Right, so in this case, we've been given a lot more information. And this question is going to be a little bit longer than the previous one, right? But again, the approach is exactly the same, right? So we've got our object, right? The first thing that we just need to do is just sketch all the forces acting on our object. So we're going to draw the plane. This is our x direction, and this is our y direction. Right, and then we're going to list all the forces that are there. Right, so we're told that it's released from rest. Right, we haven't been told that it's been pushed with any force, so maybe there is no force applied. Right, so force applied, that's gone. We already know that friction, in this case, there is no friction. So that leaves two forces. The first one is the normal force. Yeah, that's fine. All right. And then the second one is going to be weight. And again, weight is the big problem in this case because weight, let's just redraw that. Weight is the one that's not along the axis. Right, so which means we need to resolve it. And again, once you've resolved it using your triangle, because we need the x component, we need the y component, this creates a right angle triangle where this is your hypotenuse, wx is your opposite, and then wy is your adjacent. So that means if we're just going to take this back, right, if this is theta, that means we have this force in this direction, which is W cos 30 or 45, sorry, so that's our angle. Let's just call it W cos theta. We'll call this W sine theta. Right, so we're actually going to remove this weight over here so that we don't have too much going on over there. But these are the three forces that we're going to be dealing with. Normal force, weight down the slope, weight into the road, into the surface. All right, so that is how we've broken it down. And then now let's look at the questions. First one says, calculate the normal force acting on the box. When it comes to normal force, again, same as the last time. Because this box isn't going into the slope or up the slope, it's not going in that direction and it's not going in this direction. That means there is no acceleration in that direction. No acceleration, again, means there's no resultant force. So there's no resultant force in the y direction. Right, so part A, resultant force in the y direction is equal to 0. Right, since you have no acceleration in the y direction. Right, so also let's just make sure that we've specified this is y, and in this case we're going to make this the x direction. So actually let me just remove this. Right, so this would be our x since it's going down the slope. Like I said, I always like to make sure that the positive x is where the box or the object is going. Right, if you get, but it's fine because if you decide that this is your positive, if you get negative answers, you then know it's going in the opposite direction. So whatever you decide, just stick to it, just make sure you're accurate. Right, so we know that this is the resultant force, and anything that's going away from the slope is positive. This means that the normal force is positive, but this weight component is going to be negative. All right, and this would give you the resultant force, which is 0. So again, in this case, if you take the weight component to the other side, that becomes W cos. I keep saying 30. There should be 45. 45, that's your normal force. So your normal force is actually mg, since this is your weight, cos 45. Right, so if you put that into your calculator, your mass, the mass is 600, that's massive, times 9.81 times cos 45. Make sure that your calculator is in degrees. Cos 45. So that gives us an answer of 4162.0 newtons or 4.16 kilonewtons. Right, so that's part A. Part B says, explain how it is that the box is able to accelerate from rest and slide down the incline. Right, so for it to accelerate, we need to be able to quantify why it is that, obviously we're not really going to do any calculations here just yet, but we want to explain why it is that it's able to go from rest and go down the slope. Why is it that it has an acceleration? Because we know for you to have an acceleration, you need to have a resultant force according to Newton's first law and also your second law, right? So you can't accelerate if you don't have a resultant force. Now, in order for you to answer this question, you have to be able to say, well, where is the resultant force coming from? So just to go back to our diagram, we can see that there is this force over here, and it doesn't have any other forces that it's canceling it. So because you have a weight component down the slope, then that means you have a resultant force down the slope as well. So that is the reason why it's able to accelerate, because that component of weight is able to push it and accelerate it down the slope. All right, so essentially I just wanted just to go through, so maybe sometimes you might be asked a question like that, so just wanted to talk through that just a little bit for, hopefully it kind of improves your understanding a little bit. All right, that's part B. Part C, calculate the acceleration down the slope. So now we can acknowledge that there is an acceleration down the slope and we know where it comes from, so now we have to calculate it. Right, again, this comes from Newton's second law. Newton's second law says resultant force, and in this case is going to be the x direction, it's going to be equal to the mass times acceleration in the x direction. All right, so in order for us to get acceleration, I should have, we want to get acceleration, not force, right? We have to make that the subject of the formula, so that's going to be Fr in the x direction divided by the mass. Right, so once we have the resultant force in the x direction, then we can divide by mass to get acceleration. So what is that resultant force in the x direction? It is going to be W sine theta. Because there's no other forces opposing this one, we don't really need to do any calculation beyond that, right? So that's going to be W, which is mg, multiplied by sine 45. This is going to be your resultant force, and you divide this by mass. If you want to cancel those masses, that's perfectly fine. This is going to be g sine 45. If you want to be fancy, or you could have just put it into a calculator directly. That's also okay. And then that's going to be 9.81 multiplied by sine 45. Throw that into your calculator. Gives you an answer of 6.94 meters per second squared. That is your acceleration in the x direction. All right, if you had decided to make up the slope positive, you've just gotten a negative answer, which just basically means that it's the opposite of your positive, which is down, right? So it doesn't really, as long as you stick to what you've decided your positive is, your answers are still going to come out the same, as long as you don't make too many mistakes, or as long as you don't make any mistakes. All right, so that's 6.94, all right? So now we know the acceleration, so let's go to the next question. How long does the part D says, how long does the box take to reach the bottom of the slope? So now we're being asked about time. The moment it starts asking about time, displacements and so on, that then becomes a kinematics question, right? In kinematics, we always have to list our 5 variables. So this is going to be part D. Now remember, in kinematics, you have 5 variables, which are U, V, A, S, and time, right? So you have to list whatever you've been given. In this case, you always need to have 3 variables in order for you to get a 4th one. So coming back to here, we are being asked about time. So we don't know what time is. We don't know what this is. We do know what acceleration is though. This is going to be 6.9. I'm going to write it as whatever I have in my calculator, because we don't want to round up or down too early. Right, so 367175. I'm just going to write it like that. But which other variables were we given? Right, we were also given, just coming back to the question, we know that this comes from rest, which means u is equal to 0. All right, so our initial velocity is 0 meters per second. This is meters per second squared. Right, and then what other thing were we given here? We're also given the dimensions of the slope. But you're not given, in this case, you're only given the height, right? We have to know how far this goes down the slope. So we have to go back to the joys of trigonometry, right? We have this line, which is the opposite. We are trying to look for the hypotenuse. So let's just come back to this, right? So we have our slope that looks like that, right? So this is, let's go back, try that again. Okay, this is a 45-degree triangle. We know that this, since it's height versus the ground, this is going to be 90 degrees, so that's going to be 30. And this is your opposite, like we've said, and we're looking for the hypotenuse. So we need to look for something with O and H, right? So that's going to be saw from saw katoa, right? So that's going to be sine 45 is equal to opposite over hypotenuse. Sine 45 is equal to the opposite, which is 30, divided by the hypotenuse, which we don't know. We're going to call that S, since that's the displacement we're looking for. So to get the displacement, right, you can multiply both sides by S to cancel, but you have to now multiply this side by S. So now you've got S multiplied by sine 45 is equal to 30. Divide both sides by sine 45. That's going to cancel here. And now you're going to get displacement is equal to 30 over sine 45. I'm just going to leave it as this, as an exact value, so that when you put into the equation, into the calculator, it gives us a more exact value. All right, so we're looking for an equation with U, A, S, and time. That's going to be S is equal to UT plus half AT squared. All right, so this U is 0, so 0 multiplied by time, this goes away. So now you're left with S is equal to half A times squared. We're looking for time, so to multiply both sides by 2 to get rid of this half, that's going to give us 2S. Divide both sides by acceleration to give us 2S over A. So now we've got time squared is equal to 2S over acceleration, and then you root both sides to cancel that square over there. All right, so time is equal to square root of 2 multiplied by S, which is 30 over sine 45. Then you divide that by acceleration, which is 6.93 or 6.94. Right, in this case, I would advise you to use the answer function on your calculator so that you can just put the exact value into there. But we're going to put that into our calculators. Sine 45 over 6.94, which is the previous answer. That gives you a time value of 3.50 seconds. Okay, right, so we can see how kind of, we can mix these questions across different chapters and different concepts, right? So part E says how fast, as that's supposed to be, is how fast is the box moving when it reaches the bottom, okay? So now we're looking for final velocity. Final velocity, we're going to look for something with U, V, A, and S. That's going to be part E, V squared is equal to U squared plus 2AS. We're not using the one with time because maybe, you could have gotten it wrong before. So we're going to use this one. So V is equal to the square root of U squared plus 2AS. All right, so put your values into your calculator. So U is 0 squared plus 2 multiplied by the acceleration, which is 6.94, multiplied by displacement, which is 30 over sine 45. All right, so you throw that into your calculator again. Square root of 2 multiplied by 6.94, or at least use the answer function, 30 over sine 45. That gives you a final velocity of 24.3 meters per second. All right, cool. All right, so hopefully it's kind of making sense. I know we've done a lot of questions on this stuff, kinematics, dynamics, but hopefully the repetition is working. Right, final part of this video, right? So if the box were pushed down the slope instead of being merely released to slide down, right? So this implies that we have, if it's pushed down, it means we have an F applied. right? And its acceleration down the slope is 10 meters per second squared. Also, we're assuming that that force just is applied consistently as it goes down. It's always going to have that force. Now we have a new acceleration. What would be the force applied in pushing the box? Right, so the fact that you have a different acceleration tells us that we're going to have different resultant force, right? So coming back to this question, actually, let's just redraw our diagram, right? Because we still have the same slope over there, right? So we have the y. What we're basically saying is, right, we still have the normal force. This one isn't really going to matter too much in this question. We still have the weight going downwards. Again, this one isn't really going to matter. But the ones that are going to matter are going to be the weight, which is W sine 45. But what we're being told in this case is that there's another force going down the slope. We have another applied force just to make it move faster. As you can see over here, the new acceleration we've been given is 10 meters per second squared. The acceleration that we got in the previous question was 6.94. So clearly the acceleration is much more. It's being helped by that additional force. So the question is, if you have that acceleration, what is this force going to be? In order for you to get that force, you need the resultant force. Right, so based on that acceleration, what's your new resultant force? We're going to take that resultant force and then get the unknown force that we need to find in this question. All right, so that's going to be part F. So again, it goes from Newton's second law. The resultant force in the x direction is equal to the mass times the acceleration in the x direction. We have a new acceleration. The mass, before we get to that, the mass is 600. So we have 600 multiplied by the acceleration of 10. That's going to give us 6,000 newtons down the slope. You've got 6,000 newtons. That's coming from Newton's second law, right? But now we also know that in order for you to get this resultant force, you also need to add all these forces here. So resultant force in the x direction, if you're taking down the slope as positive, is equal to, right, force applied plus, since they're both going down the slope, they're both going to be positive, W sine 45. This should give you an answer of 6,000. So once you've added these, they should give you this resultant force. So F applied plus mg sine 45. All right, so in order for you to get F applied, you're going to take this expression, take it to the other side of the equation. So that's going to give you 6,000 minus mg sine 45. By the way, mg came from W, just in case you're lost there. Right, so your force applied is going to be 6,000 minus this expression. 6,000 minus the m, which is 600. Did we use 600 before? I just need to make sure I check that. Yeah, we did use 600. Okay, 600 multiplied by 9.81 multiplied by sine 45. If you put that into your calculator, that gives you a force applied of 1837.97 or 1838, right? Or you can say this is 1.84 kilonewtons down the slope. Okay, so that is your force applied. Okay, right, so these are more, again, right, so these are more complex questions, I guess, for your exam prep, but hopefully it kind of makes sense. I know these videos are really long, but hopefully, by the time you finish it, hopefully it kind of makes a little bit more sense how to break these down. But once you get these, you kind of have a basic understanding. I do then encourage you just to look at some of the exam questions and exam videos. Right, but for now, we're going to stop right here. And hopefully this was helpful. And as usual, I'll see you in the next video.